Lighting contactors mounted directly to the back of a metal enclosure can generate noise due to vibration. Several methods can be employed to dampen this vibration and reduce noise transmission. One approach involves using anti-vibration mounting pads. These are adhesive-backed rubber or silicone pads that are applied between the contactor and the enclosure to absorb vibrations. Another method is to install vibration-isolating mounts. These mounts, typically made of rubber or springs, are placed between the contactor and the enclosure to deflect vibrations and prevent them from reaching the enclosure. Encapsulated contactors, which are contactors encased in a noise-dampening material, can also be used. The encapsulating material absorbs vibrations and reduces noise levels. Acoustic barriers, such as foam or fiberglass, can be installed around the contactor to absorb and dissipate sound waves. To reduce vibration transmission through wiring, flexible conduit or whip tubes can be used to connect wiring to the contactor, decoupling the wires from the enclosure. Applying a thin layer of damping compound, such as silicone sealant or sound-absorbing paint, to the contactor housing can also absorb vibrations and reduce noise. Soft start or stop contactors can minimize the initial surge of vibration when the contactor engages or disengages. The enclosure design can also play a role in noise reduction. Enclosures with built-in sound dampening features, such as acoustic panels or sound-absorbing paint, can help contain and absorb noise. It is important to properly secure the contactor on a flat and stable surface and avoid placing it directly on metal studs or beams, which can amplify vibrations. Therefore, firstly, anti-vibration mounting pads made of adhesive-backed rubber or silicone can be applied between the contactor and the enclosure to absorb vibrations and reduce noise transmission. Secondly, vibration-isolating mounts, typically made of rubber or springs, can be installed between the contactor and the enclosure to deflect vibrations and prevent them from reaching the enclosure. Thirdly, using encapsulated contactors encased in a noise-dampening material absorbs vibrations and reduces noise levels. Fourthly, installing acoustic barriers such as foam or fiberglass around the contactor can absorb and dissipate sound waves. Fifthly, decoupled wiring involves connecting wiring to the contactor using flexible conduit or whip tubes, decoupling the wires from the enclosure and reducing vibration transmission. Sixthly, applying a thin layer of damping compound, such as silicone sealant or sound-absorbing paint, to the contactor housing can absorb vibrations and reduce noise. Seventhly, using contactors with soft start and stop features minimizes the initial surge of vibration when the contactor engages or disengages. Eighthly, enclosure design is important, so consider using enclosures with built-in sound dampening features such as acoustic panels or sound-absorbing paint to contain and absorb noise. Finally, proper installation is crucial, ensuring that the contactor is properly secured on a flat and stable surface and avoiding placing it directly on metal studs or beams that can amplify vibrations.